Hello. This time I would like to explain one problem about the test for symmetry. This is a problem number 85 from our Pearson Precalculus textbook. I spelled this one wrong. So here's the problem. For a non-zero constant, find the intercept of the graph of this and test for symmetry. And test for symmetry. Hi. Okay, so to find the intercept, you just set x is equal to 0 and solve for y. So let's find intercept first. So to find x-intercept, you are going to set y is equal to 0 and solve for a real solution, solve for x in real numbers. So assume a is a non-zero constant and you're gonna set y is equal to 0. So it's gonna be x squared plus 0 squared, which is 0 squared, and that is equal to a squared x squared minus y squared. Now, oh, sorry, this is incorrect. I set y is equal to 0. So it's gonna be like this. So this is simplifies to x to the power of 4th is equal to a squared times x squared. So this is a polynomial equation of degree 4. So we are going to solve it by factoring. Bring a squared x squared to the left side of the equation to set right-hand side is equal to 0, and we are going to factor it. And you can factor a bit more, like this. So the x-intercept will be 0 or a or negative a. Likewise, let's find y-intercept. To find y-intercept, you are going to set x is equal to 0 and solve for a real value y. So again, looking at this, we are going to set x is equal to 0. So 0 squared plus y squared is equal to a squared 0 squared minus y squared. So this reduced to y to the power of 4th is equal to minus a squared y squared. Again, this is a polynomial equation of degree 4. So let's factor this one. So y to the 4th plus a squared y squared is equal to 0. And factoring x y squared out. So you get this. Unlike the difference of squares, the sum of the squares cannot be factored. So the real solution would be only from here, which is y is equal to 0. Since this is a is positive, a squared is positive, this has no real solution. Okay, this has no real solution. So the only real solution is y is equal to 0, and that's gonna be the y-intercept. Now, next, we are going to do the testing for symmetry. Now, to test for symmetry, this is asking for whether the graph of this graph given by this equation is symmetric with respect to x-axis. Is it symmetric with respect to y-axis? And is it symmetric with respect to the origin? To test for this symmetry, we are going to replace x and y in these ways and to see whether we are going to get the equivalent, identical expression from the original one. Okay, so for first test for symmetry, with respect to the x-axis first. To show the graph of the equation is symmetric with respect to x-axis, we just need to replace xy into x and negative y. Okay, not x, but y, you want to change the sign. So if the graph goes through a point xy, and if it is symmetric with respect to x-axis, it must also have a point x minus y. So substitute y by negative y, you're gonna get x squared plus minus y square is equal to a square x squared minus y squared. Okay, but minus y squared will become y squared because you multiply negatives twice. And again, this is gonna be like x squared minus y squared. So this is equivalent to this original expression. So the conclusion is the graph is symmetric with respect to the x-axis. So we are going to do kind of same thing for testing for y, test for symmetry with respect to the y-axis by almost identically xy replacing by negative x and y. Okay, if the graph goes through a point xy and if it is symmetric with respect to y-axis, then it must also contain negative x and y. So substituting x by negative x, you are going to get this. But again, because negative x squared become x squared, it will be identical, equivalent from the original expression, which is equivalent to the original expression. So the conclusion is, yes, it is symmetric with respect to the y-axis, x-axis. Okay. Last thing is test for symmetry with respect to the origin. It's almost identical. You replace x and y by negative x and negative y. So the original expression will be negative x squared plus negative y squared is equal to a squared negative x squared minus negative y squared. But since all of them are negative square, it's going to become this. And this is exactly identical to the star, equivalent to the star. So the conclusion is this: the graph of this one is symmetric with respect to the origin. Okay. So when you are not sure about your answer, if you have a graphing utility, you can just type in the expression, given expression, to see whether it has any symmetry. So let me show you the Desmos. So this is expression I just typed in the Desmos calculator. And this is just, I set a is equal to 7. But for any value of a, I mean, except for 0, the graph looks like this. And indeed, looks like symmetric with respect to the x-axis, y-axis, and the origin. So that concludes the explanation for this program.